Hi, Geo 131. I keep meaning to get a ring cam. That would really improve things, but oh, well, I have one. I just keep forgetting to bring it in. Let's see if I look these videos evolve in quality as we go through the semester. So this week it's earthquakes. This is not a terrible lab as long as you can get Google Earth to work. So let's go ahead and get started, and I'm going to share my screen. Let's share that screen so we can watch this together. And then I'm going to bring this over. Now, the step that gets people messed up, make sure that you download that Google Earth Pro. Okay? Like this is what you want. Am I sharing and recording? You are sharing. Ooh, I'm just gonna stop share for a second, make sure I'm recording. Yeah, I'm recording. And I'm sharing the correct screen. Excellent. So make sure you have that downloaded. If you have trouble with that, which that's a normal thing, shoot me an email. That's not Science Interactive's fault. I will try to you through it as best I can, just keeping aware that I'm not always comfortable with Macs, but there's a lot of, because Google Earth is used a lot, there's a lot of solutions online to that. So as long as you got your Google Earth, let's pretend you've already downloaded it, follow the directions, installed it. Now, your next thing is what you're going to do is you're going to download this seismograph locations KMZ file. And you can see it's up here. You open it. Some people, some computers, you may have to open your download file. Click that and it'll launch and do everything correct right into Google Maps. Okay, so you don't have to have Google Maps already open. You just need to have um, you just need to click on that KMZ file. So let me go ahead. I'm just going to move this out of the way, move this to the other screen so I can switch back and forth a little bit. Okay. So you're going to zoom out. All three stations are visible. I'm going to keep moving this back and forth to show you the directions. So I'm now on step 5. Zoom out until all three stations are visible. Now there's a couple of ways to zoom out. I'm just using the scroll on my mouse. I'm just scrolling back and forth. So if you scroll, that's the little wheel in the middle of your mouse. I know not everyone's comfortable with that. Your laptop should also have a scroll. You can also scroll like move Earth that way, but you can also woo in and woo out with this little nav bar here. But I think the scroll is pretty easy. And then you grab and turn it. I mean, if you've done any kind of computer games, this is going to be pretty straightforward. Um, if you haven't, that's okay. That's not a prereq for this class. But if you've played any video games in 3D, and I even mean like Halo, because I was a big Halo person. That dates me. Um, I played Halo 1 and was like, wow, look at those graphics. Okay, that was a side quest. Let's get busy. So, open the tools menu and select. So now we're on step 6, where it says open the tools menu and select options. So we go to tools, we go to options. And under the 3D view tab, find under step 7, under 3D view tab, find the show lat long box and select the decimal degrees button, click OK. And then view menu and select grid. So we're going to go ahead and do that. We're going to go here. We're going to go, where's lat long? Show lat long, that's this box here. We're gonna go decimal degrees. Button, boop. So we're like that. We click apply or click OK, either one of those. Then we're gonna go to the view menu and select grid. Boop. Ah, now I have my Latin longitude. So Latin longitude as a quick review, are lines on the Earth to determine if it's latitude, then it's how far north and south you are. There are lines going this way, you go further north, further south. Lines going this way tell you how far west you are, how far east you are. Click directly on one of the blue underlying names for the 3 seismograph stations. I'm on number 10, listed in the Places menu on the left-hand side of your screen. Boop. Aha! So here's my seismogram. A picture of a seismogram for that station will appear. Record the lat and longitude for each station in decimal degrees in data table 1. So where's data table 1? So I don't know why they organize it. Personally, if I were designing a lab, I'd put the data table right where you need it. But for number 11, you want to put each lat longe down here. So I'm going to go ahead and do that. I'm going to do this for HPKS. Where is HPKS? So here's the lat longe. It's actually listed on the seismogram. So you can see Poshan's Hong Kong, and it's 22 degrees, 0.28 lat and 114.14 longe. So I'm just going to go ahead and do that. 22.28 and 114.14. Boom. Where'd it go? Where'd my thingy go? Boom. And now I have it. Why is it not coming over? This is the tab I want. Oh, here it is. Okay. So now I have it entered in my data table. So we go back to Google Earth. And once again, that's all the way at the bottom for reasons that are absolutely mysterious to me. Use a seismogram to determine the P wave and S wave arrival times at each seismogram. So this is a little hard. Every seismogram has 3 groups of wiggles: the P wave, the S wave, and the surface waves. So your P wave is your first group of wiggles. So that's these group. And this one, they're low and strong. This is your second. This is your S wave. And then over here, these are your surface waves. If we look at the second one, P, S, surface. So they change shape and intensity. Let's take a look at this one. P, S, surface. Okay. This one's pretty close to the epicenter, so we've got a lot of little tiny stuff this one is a different distance from the epicenter, so this has got a lot of teeny tiny stuff at the start of it, a lot of noise. This is just noise. This is your P wave. Usually a P wave will have a little spike at the beginning of it. Their diagram of P, S, and surface waves is a little confusing, so I hope everybody watches this video. So we're gonna do the arrival times. So how am I gonna do arrival times? I'm at Hong Kong. I'm gonna do this arrival time. So notice each one of these big hashes on this one is 1 minute. So this is 3 minutes and 3 hours and 32 minutes. This is 3 hours 34. So this is 3 hours 33. It's backwards from that. So let's take a look. And in between, there's 4 hashtags. So those little tiny ones, those small ones that only go above the x-axis, those are each 15 seconds. So this is 331, 331.15, 331, 331.30, and then 331.45. So our start of our P wave is 331.45. And go ahead and put that there. I'll show you the table, and then we're going to do the S wave. And that is over here. So this is 336. This would be 337. So 330, 336.15, 336.30, 336.45. Is it perfect? No, but we'll do it. We'll do an estimate. Okay, we're eyeballing this anyways. Now it's the difference in times. So this is 3 hours, 31 minutes, and 45 seconds. This is 3 hours, 36 minutes, and 45 seconds. How much time is in between these two times? I'll give you a moment. Let's do a Dora the Explorer. How much time is in between them? 5 minutes. Awesome, you got it. 5 minutes. Boom. Now, we're on time travel, record the data, calculate, record that in data one. And then you use the difference in the arrival times between, we're on number 16. 16 isn't a direction. It's just, I don't know why it's step 16. You don't have to do anything. It's just going to use it. So we're going to open the seismic time travel chart. We can do this with a piece of paper. I'm going to eyeball it. So we're looking for a time difference of 5 minutes. So we're looking for a 5-minute time difference. On this one, notice that the dark lines, I'm going to control zoom a little, the dark lines line up with a minute. So I'm looking for one, let's see if this is the right spot. 1, 2, 3, that's not 5 minutes. Let's go a little further out. Here we have 1, 2, 3, 4. Oh, that's a little bit too much. Let's crank it back a little. See over here. Now I'm going to count from the 2 to see if 1, 2, 3, 4, and 5. So this line here is a 5-minute gap right here. Let's scroll down and see what that correlates to. Now, if you want to print this out and do it by hand, that's usually 100 times easier. Here we go. There's a lot of graph reading in this, which is why you have to be out of remedial math to do this class. So if you're like, I'm not out of remedial math, Dr. E, reach out to me. I will help walk you through this, okay? I know sometimes advisors get a little enthusiastic with putting people in this class. They're like, it's fine, you're in remedial math. No, there's a lot of graphs in this. Okay, so we're here in between the 3,000 and the 4,000. How much is each one of these worth, each one of these lines? Well, there's 5 of them, and it goes from 3,000 to 4,000. So that must be 200, 400, 600, 800, 1,000. There we go. So this one here, the second one right here is 200, 400, 600. So that means that 5-minute gap correlates to 3,600 kilometers away. Make sure you include the units to help it make sense. Scroll down. And now look at that. I've done the entirety of table 1 for you. This is what table 1, and I recommend you walk through your Hong Kong just like I walk through. If none of it, like if you walk through it and you get radically different numbers, reach out. But these are the numbers I got right here. Okay. So let's scroll back up. And then you do that for all 3. And then, okay, so the next step, so we walk through everything. We're now at step 19. Go to the Science Interactive KML circle generator. Boom, click. Here we go. select the kilometers button if it is not already selected. Kilometers, kilometers, kilometers. Use the information you supplied in data table 1 to fill in the fields to generate the circle. So we're going to just basically take this information and put it over here. So I'm literally just going to copy, boop, paste. Boop. That'll be our circle 1. Copy, boop, paste. Boop. So this is where it tells it to put the center of the radius. Now we're going to go ahead and go down here and get the distance from the epicenter. 0.1. We can also, because this is the Hong Kong, we can call it 0.1. We can also call it, what did they label that? HK, what is the label? That's the real name. HKPS. So I'm going to also label it just to make sure that on our graph, we can correlate it. 0.1 HKPS. Create file. I'm just going to put 1 and 1 because we're just going to have points there because I don't have all of them. I'm just open that. Look at that. Look at that. That's 3,600 miles. Now I have my circle for Hong Kong. You're going to do that for all of them. You want to put all of them in and then generate it. I'm just doing Hong Kong as an example, okay? I'm walking through Hong Kong for you, so as an example. Then when you find the intersection, you're going to put a push pin that's usually not people's problem. You're also going to save image, select, upload your image to image 1. So you can save the image and you're going to upload it. I know people have had trouble uploading files. Just email me if that's the problem. If I grade it wrong, just email me again. There's been a lot of glitches with this website. I believe you. If there's a problem and you say there's a problem, I will believe you. I think that's the simplest answer. And that's pretty much it for this lab. So I hope that was helpful. If it wasn't, reach out to me and yell at me, but I want you to get I want everyone to get an A. I don't see why you shouldn't get an A if you're doing the work, you know. It's my responsibility to help guide you towards the direction of the A. So reach out to me, ask me questions. Let's get you that A, right? That's what we both want. So let's do it. So, and I can only help you if you tell me you need help because like it's an online class. I can't look at your face and be like, that person looks confused, which is how you do it in a classroom. Here, you got to send me an email. So I hope this was helpful. I hope this brightened your day. Thank you for being my student, and I will see you in our next video next week.